I'm glad you're joining me on this fascinating journey into one of the universe's greatest mysteries, the mysterious black hole. Black holes are not only the most extraordinary and mysterious objects in our universe, but they also challenge our understanding of reality itself. Today, we're going to gently peel back the cosmic curtain and explore exactly what might happen inside these cosmic giants. Sit back, relax, and prepare to let your mind wander across the universe as we dive deep into the astonishing world of black holes. Now, let's start gently. Imagine a star, a massive, luminous ball of gas glowing brilliantly in space. Stars live and eventually die, just like everything else in our universe. And when some especially large stars run out of fuel, they undergo a cataclysmic collapse, causing a massive explosion known as a supernova. If what's left behind after the explosion is heavy enough, gravity takes hold and keeps pulling inward. It never stops. Eventually, gravity becomes so intense that nothing, not even light, can escape. At that very moment, a black hole is born. So what exactly is a black hole? Think of it as a region in space where gravity is so unbelievably strong that it warps the very fabric of space-time itself. To better understand this, imagine placing a heavy bowling ball on a stretched-out sheet of rubber. The sheet sinks downward, creating a dip around the ball. Similarly, black holes create extreme dips in space-time, but infinitely deeper and infinitely stranger. Anything that crosses the boundary we call the event horizon, the point of no return, gets swallowed up and never returns. Even beams of light moving at an incredible 299,792 kilometers per second can't escape this gravitational prison. That's why they're black. There's literally no visible light escaping them. But what exactly happens if you dare to enter a black hole? Suppose you're an intrepid astronaut bravely approaching the event horizon. To someone watching from a safe distance, something incredibly strange seems to happen. Your spacecraft slows down dramatically as it nears the event horizon, eventually appearing to freeze in place. From their viewpoint, you never quite enter the black hole, you simply become suspended in time. But from your perspective inside the spacecraft, reality is altogether different and even stranger. You wouldn't feel any sudden pause or freeze. You'd simply drift past the event horizon without even noticing a clear boundary. Initially, you'd see the universe around you distorted by extreme gravitational lensing. Light bending around the black hole would create a breathtakingly bizarre visual spectacle, but you'd feel relatively normal at first. Gradually, however, gravity would pull more strongly on your feet than your head, stretching you slowly and uncomfortably, a process scientists amusingly call spaghettification. But in massive black holes, like the ones at the centers of galaxies, this stretching might be gentle enough to allow you to survive, at least briefly, past the event horizon. Now, as you drift deeper into this mysterious realm, time behaves differently. In fact, conventional understandings of space and time cease to function inside the black hole. Normally, space and time are separate but closely linked. Inside a black hole, however, the roles of space and time might reverse. What used to be your forward direction in space becomes your inevitable journey forward in time, pulling you relentlessly toward the black hole's center. No matter what you do, you're drawn deeper and deeper toward a singular point, the singularity. This singularity is one of the universe's most profound mysteries. It's a place where gravity compresses everything into a single, infinitely dense point. Here, all known laws of physics break down. Our mathematical equations can't handle the infinite density and gravity we encounter at this point. Einstein's theories tell us clearly what happens around the event horizon, but they fail spectacularly at the singularity. Physicists are still working tirelessly to understand this puzzle, hoping quantum mechanics and theories of quantum gravity might one day explain what exactly happens there. In reality, no one truly knows what happens when matter reaches a singularity. Does it disappear entirely? Does it emerge in another universe? Could it form a tunnel? A wormhole? connecting distant parts of space, or even entirely different universes. It's all speculation, but exciting speculation at that. Some theories suggest black holes could indeed be doorways to other universes, opening pathways through something called the multiverse. Others propose that black holes recycle matter and energy, perhaps slowly evaporating and returning their contents back into the universe through radiation. Speaking of radiation, black holes aren't exactly eternal. The brilliant physicist Stephen Hawking discovered that black holes actually radiate very slowly, in a phenomenon now known as Hawking radiation. Although this radiation is incredibly faint and takes unimaginably long timescales, billions upon trillions of years, eventually black holes lose their mass completely and evaporate into nothingness. A mind-blowing concept indeed. Now, the largest known black holes, the supermassive black holes, live in the hearts of galaxies. Our own galaxy, the Milky Way, houses Sagittarius A, a supermassive black hole containing over 4 million times the mass of our Sun. Scientists are still trying to figure out how these gigantic black holes got so enormous. Did they start small and grow gradually? Or did massive gas clouds collapse directly into giant black holes early in the universe's history? The truth remains tantalizingly out of reach, but each new discovery gets us closer. Astronomers today rely on brilliant technological advancements like the Event Horizon Telescope, a network of radio telescopes that recently captured the first ever direct images of a black hole. What we see in these remarkable images isn't the black hole itself, since no light escapes, but rather the glowing gas swirling around it, heated and accelerated to nearly the speed of light. These glimpses into the universe's most mysterious places captivate us and remind us how incredible our cosmos truly is. Yet, with every discovery about black holes, we're faced with even more fascinating questions. If black holes can merge, what happens to their singularities? Can we eventually harness their unimaginable gravitational energy for interstellar travel or advanced technology? Will understanding them help unify the great mysteries of quantum physics and relativity? Black holes compel us to think bigger, deeper, and with greater humility about our place in the cosmos. They remind us how little we truly understand, and yet how thrilling it is to seek those answers. Whether they're cosmic recyclers, pathways to other universes, or simply nature's greatest mysteries, black holes offer endless opportunities to expand our knowledge. So here we stand, humbled before the universe's most fascinating mystery. We've traveled from the gentle death of massive stars to the bizarre realities lurking just beyond black holes' event horizons. We've glimpsed into regions where time and space merge, twisted into forms we can scarcely comprehend. And while black holes might forever remain mysterious, the journey toward understanding them enriches humanity. It teaches us about the universe and ultimately about ourselves. Thank you for joining me on this cosmic exploration into the astonishing mysteries of black holes. Keep wondering, keep questioning, and always look up at the stars with curiosity and awe. Remember, the universe is filled with mysteries, and perhaps none so fascinating as those mysterious, elusive black holes. Until next time, keep your eyes on the cosmos and your heart open to the endless possibilities of discovery.